Alright, in this lesson we're going to look at projectile motion, and projectile motion talks about any type of object that's thrown or launched or rolled into the air and is flying under the influence of only gravity. This is two-dimensional motion where the acceleration of the object is only due to gravity. In this case, the horizontal motion, what happens side to side, in my chart over here, the blue line, or the blue arrows, remains unchanged. There's zero acceleration horizontally, and the vertical motion looks like free fall. The acceleration is negative 9.8. Slows down going up, speeds up in the negative direction going down. Some techniques for solving projectile motion problems. The first thing to do is to define what direction is x and what direction is y. Generally speaking, it makes sense to make the right the positive x direction and the positive y direction. The second step is to do what I call separation of variables. Take and separate what's happening in the x direction and what's happening in the y direction. What's happening with horizontal motion versus what's happening with vertical motion. Look for shared variables. Are there some things that are shared between both horizontal and vertical motion? Time is probably the most common example of a shared variable in projectile motion. Also look for known variables that may not be given directly to you in the problem. Acceleration is an example of a known variable almost always, or is almost never given to you in the problem. The acceleration in the x direction, if you've made x horizontal, is 0. The acceleration in the y direction, if you've made y vertical, is negative 9.8. At the highest point, the thing to remember is that the velocity in the vertical direction is 0 at the highest point. The velocity in the horizontal direction probably is not 0 at the highest point. Let's look at an example problem. And so here we have an airplane that's moving horizontally at a speed of 115 meters per second and an altitude of 1,050 meters drops a care package. We want to determine the time that it takes for the care package to hit the ground and the horizontal distance the package would travel from the point of release. Now, the one thing to point out here in this problem is that you're releasing the package from its highest point in its motion. This package is going to fall from the point it's released at the airplane. If we start to identify some known variables, first thing we know about the airplane is we're traveling 115 meters per second in the horizontal direction. I know the horizontal direction has 0 acceleration. If I'm dropping this package from the highest point in this motion, which is probably true in this problem, if we draw a picture of this, we see the package falls out of the airplane. Its velocity is 0 initially in the y direction. We know the acceleration, negative 9.8. And I know in order for the package to hit the ground, it has to fall 1,000 meters. So the distance traveled in the y direction is negative 1050. Now I've put an arrow here with time because I know time is going to be a shared variable. The time it takes for the package to fall is going to help me determine how far horizontally did this package travel. The time will be a shared variable. Really, my first step here will be to try to solve for time. I have enough information on the y side of stuff to solve for time. The initial is 0, so y is equal to negative 1/2 at. Multiply both sides by 2 to get rid of the half. Divide both sides by acceleration, and then square root both sides. So I get the time it takes to fall is square root of 2y over a. Now if I substitute in my numbers, what I get is it's going to take 14.6 seconds for this package to fall. Now I know the amount of time over here on the x side of things. If I have 3 of the 5 variables, I can solve for the other 2. And I'm interested in solving for x. So first thing, the acceleration in the x direction is 0. So x is just equal to v0 times t. If I substitute in, what this means is that the package is going to travel 680 meters horizontally from the time I release it until the time it hits the ground. So if horizontal and vertical motion are independent, if I want to release this package and have it hit a target, I have to release it when my plane is 1,600 meters before it gets to the location that I want to hit that package. Let's look at a second example problem. This is what I call, this problem here, 2.7 is what I call a horizontal launch problem. It's an example of what I call an angled launch problem. We're going to have a cannon that launches a cannonball at a velocity of 50 meters per second and an angle of 30 degrees above the horizontal, and I want to figure out what is the range of the cannonball. The very first thing I probably want to do is start to break things up into the x and y direction. I want to figure out what is the initial velocity in the x direction. We'll break up this vector 50 meters per second at 30 degrees above the horizontal into its x and y component. And I get 43.3 is the x component there. and 25 is the y component. From there I can plug in the things that I know. I know AY is negative 9.8, I know V initial Y is 25, I know AX is 0, and V initial X is 43.3. And when it asks what range of the cannonball, it really wants to ask what distance X am I able to launch this cannonball. So there's some other things that we could do in order to find a variable. Probably what the most logical thing to do would be to figure out how long it takes for the cannonball to reach its highest point. If I can figure out that amount of time, the total time of flight has to be double that amount of time. It takes to get to the highest point from the ground, and the time it takes from the highest point back to the ground are the same. Now, if I want to figure out how long it takes to reach its highest point, I know the vertical velocity is 0 at the highest point, and so now I have 3 variables on the y side of things that I can solve for time, which will be a shared variable. So if we solve it for time, I have v is equal to v0 plus at. If I solve that for t, subtract v0 and divide by a, I get the time it takes for the cannonball to get halfway up is 2.55 seconds. What that means is the total time of flight is twice that. Excuse me, should be 5.1 seconds. We're going to work through this. Excuse me here. I wanted to check something. This total time of flight should actually be 5.1 seconds twice this. But if you plug 5.1 seconds in for t with v0x times 5.1, you get 221 meters. What that means is you can launch this cannonball 221 meters with your cannon. So, it's kind of an overview of projectile motion and problems that deal with projectile motion. What we'll start looking at in the next lesson is some graphs of motion.